Hello guys, in this video we will see what do we mean by language model and how we can build a language model. So till now we have understood what RNN is, how do we forward propagation, how do we do back propagation, how do we update the weights and bias, right? So why we do that? In order to build the language models. So what are some examples of language models? If you have heard about Apple Siri, Amazon Alexa, Google Assistant, these are all example of language models, and basically they comes into a category of speech recognition, right? They will have a trigger word, hearing that it will be triggered and then waits for the command. So that's one set of language models. Another set would be machine translation, right? So from one language to another language, German to English, English to Spanish, French to Spanish, French to English, English to French, Russian. So anything, it could be anything. So that is another category of machine translation. Another thing could be, you can think of as a sentence completion, right? Sentence completion. So what do you mean by sentence completion? So if you have seen Google, while you write the email, if you type something, it gives us some suggestions, right? For the next few words, correct? So that's what I mean by sentence completion. So for all these tasks, we need a language model to be trained so that we can get the desired output that we want. Okay. So as I told you earlier, how do we build a language model? We make use of RNN, right? So let's say I have a sentence. Let us understand building a language model using RNN with the help of one sentence here. Okay. So I'll say my neighbor has a dog and it is a Jack Russell Terrier. Jack Russell Terrier. So Jack Russell Terrier, it's basically a breed of dog, one kind of dog. Okay. So if I want my language model to output this sentence, if I give some inputs to it, I need to train a language model. So what are the steps for that? First, I need to have a corpus which I will be making use to train. Okay. Then I need to prepare a vocabulary. So what is this vocabulary? I need to tokenize the entire corpus and then separate out the words. So this will be my vocabulary. So let's say I have a vocabulary of 1000 words. Okay, just for the sake of understanding, let's take I have 1000 words in my corpus. 1000 unique words in my corpus. Okay, so that's the length of my vocabulary. Now, how do I train an RNN as a language model? Let's see that. So we know the basic architecture of RNN. So I'll just write it in a shortened way. I'll have my X1. I'll have the activations at first time step. I'll have the predictions. Correct? And starting at time step 0, I'll have the activations at 0, which will be equal to all vectors. It's a vector of all zeros. Okay. So this is my first block of RNN at time step t. So now what I'll do, I'll have multiple time steps. So I'll just repeat the same block multiple times for multiple time steps. I'll have A2, I'll have X2, I'll get my predicted y hat 2, right? Then I'll have this input to get my A3. It will be X3, output will be y hat 3. So in order to stop at somewhere, we may need to have something called as end of statement, EOS. Let's call it as an end of statement token. So once we encounter this, we need to stop our sentence generation in our language model. Okay. So what I'll do, I'll say XTX, I'll have y hat TY. Okay. And this will be ATY. So what are this TX and TY? Length of input sequence, length of output sequence. Okay. So for now, assume TX is equal to TY. So if we have 10 tokens in our input sentence, we are expecting 10 output tokens. Okay. Just for simplicity. Now what happens? I have this basic RNN model, and if I want to train this model in order to complete my statements, so this is how I will do. So starting at time 0, I'll feed in all the vectors of vector of all the zeros, and x1, this will be equal to a0. Okay, again it's a vector of all zeros, just like this. Okay, so I'm basically feeding x1 is equal to a0 into as an input into this RNN unit, and I'm getting some predictions. What are this y hat of 1? So this y hat of 1, these are the predictions across my vocabulary, and my vocabulary is of size 1000, correct? 1000 words. So what is this actually y hat? So this will be a softmax predicting the probability of each words in a vocabulary across these 1000 words. Okay, so this will be my y hat 1. So in order to predict y hat 2, in order to have my second token predicted, what I will do, I will give input as actual y1 as my x2. So understand this. What is my y1? If we consider this sentence, this one sentence for training, my y1 will be my, the word my. So in this case, x2 will be my. I'll pass it on as an input to my RNN block to have my predictions y hat 2, right? So what is this y hat 2? Again, this is a softmax across 1000 words, but now in this case, it will be the probability across all those 1000 words given the word my, correct? In this sentence, the first word is my. Now this will be a conditional probability, right? Conditional probability. What is the probability of each of my words in the vocabulary given the first word as my? So now I will have my predicted y hat 2. Okay. Now what I'll do, in time step 3, I will give input x3 which will be equal to y2, that is neighbor. So this will be y2 which will be equal to neighbor. So I am actually giving the actual words that I want it in that particular time step as an input at this particular time step, which is third time step. Then I will compute my y hat 3. Okay. So what is my y hat 3? It's again a prediction. This will be again a probability of each word given the word neighbor. Again, this is a conditional probability. And what is this output? It's actually a softmax across all of my 1000 words in the vocabulary. So this is how we train a RNN for a language model. So now we have to arrive at a step where we need to have the predictions right. So if I give input as word my, I want it to predict neighbor, right? If I give word neighbor as input, I want it to predict the word has, right? So that I'll have the expected statement as my output. If I combine all the predicted words, I will have the expected statement. So now how we will train this to that particular task? So for this, what we will do, we will define a loss function, correct? And since we are using softmax as an activation function at each output, we will use the loss associated with softmax function. Okay, so let's not bother about what that particular loss is with respect to softmax. Okay, let's concentrate on how do we train it and what do we do after training it. Okay, so now we have defined the loss. What we do, we will back propagate through time t and then update the weights, right? So this layer, this RNN model will have the weights, right? This will have wx, this will have wa, this will have wy. So the same weights are shared across multiple time steps, correct? So in the end, we have to update these weights. How do we update these weights? Using the formula wy is equal to wy minus derivative of loss with respect to wy. Similarly, wa is equal to wa minus, so I'll have my learning rate multiplied to the gradient, okay? Wa minus learning rate multiplied by derivative of loss with respect to wa and Wx will be equal to Wx minus learning rate multiplied by derivative of loss with respect to Wx. So this is what we do in order to update the weights, correct? This we have already seen in my back propagation video. So if you guys have not seen my back propagation video and how do you update the weights, please go back to that video and refer that. You will have the understanding. So what we do, we back propagate through the time, update these weights. Why we do this? In order to reduce this loss. So we need to arrive at global minima. Right? When we arrive at global minima, our language model or RNN model will do a fair job in completing this sentence if we give 1-2 words as input weight. Okay? So this is how you train a RNN as a language model. Okay? Now after you learned the language model, after you have trained an RNN model as a language model, what you can do with it? So you can sort of have fun with it. So what we can do, we can make use of something called as sampling. Okay, sequence sampling. It's also called as sequence sampling. So what we do in this case, so we will have a similar architecture like this. I'll just quickly draw that. So I'll have my A1 input X1. So now treat this as my trained RNN language model. Okay. Okay, X3 output will be Y hat 3. This will be Y hat 2. This will be Y hat 1. Okay. And I'll have for Tx or Ty out. Let's say Ty. Prediction will be Y hat Ty. Okay. So, how do we know where to stop this? Maybe we can have a fixed length of words required in the sentence, or we can do this, repeat this prediction till we encounter end of sentence token. Okay, we can do this. Now, I have told you this is a trained RNN model, right? Trained RNN model. So how do we do sequence sampling in order to generate some text out of trained RNN model? How we can do that? So what I'll do, so here I'll have A0, which is a vector of all zeros. This will be A0. Okay. So now what I'll do, at time step 1, I'll feed in the vector of all zeros and I'll have my predictions Y1, Y hat 1. Okay. So what is this Y hat 1? It will be a softmax across my 1000 word vocabulary. Correct? So then what I'll do, I'll have the probabilities for each of the words. Okay. I'll have something like this for 1000 words. So what I'll do, I'll randomly pick some word out of this distribution, maybe using something like np.random.choice. Okay. I'll get some word Y hat 1. Now in order to predict my second word, that is Y hat 2, what I'll do, I will give this predicted Y hat 1 as input to my second time step. So instead of giving actual Y2 as we did during training, I will give Y hat 2 as an Y hat 1 as an input to my second time step prediction. So X2 will be equal to Y1. Okay. And I will have my predicted Y2, Y hat 2. This is also probabilities across 1000 vocabulary that we have. Okay. Again, what I'll do, I will use something called as np.random.choice and then select one word randomly, and I'll feed that randomly selected word as input to my next time step, that is X3. So my X3 will be equal to Y hat 2. Then I'll go on continuing this procedure till I encounter either end of statement, or let's say initially while doing this sequence sampling, I have fixed my mind that I want a sentence with 10 words or 13 words or 15 words in it. So after I encounter those many words, I will stop it. So this is how you can do sequence sampling once you train your RNN model as a language model. So what you can do with this, you can have your own text generated. Okay. So let's say if you have trained your RNN model as a language model on poems of Shakespeare. Okay. So once it is trained, then if you use this sequence sampling method out of this trained model on Shakespeare poems, you will have your own Shakespeare model ready, and you will be seeing the outputs which are not even composed by Shakespeare's, right? That's possible. So you can do all of these stuffs once you train your model on some corpus and then do the sequence sampling. So most probably in my upcoming videos, I will try to implement this, okay? And then we will see how we can generate our own Shakespeare-like text or something else, right? So till we see in the next video, guys. Hope you understood this. If you are liking my content, please give it a thumbs up, share it across your friends so that they can also learn. And do not forget to subscribe to my channel. I'll be sharing many more quality contents like this, okay? So see you all in the next video. Happy learning. Bye bye.